Good morning, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CCNP Switch course, and this morning's video tutorial is going to be on Cisco Discovery Activity number 8, where we're going to be focusing in on RootGuard, one of the tools in the Spanning Tree Toolkit. And as you can see, we've got our topology here, so we're going to go ahead and jump in. If you're following along, we're on step 1, so let's go ahead and validate the spanning tree topology real quickly. So we're going to go from user exec into privilege exec, and I'm going to say show spanning tree. So if we take a look here, what do we see right out of the gate? We see that all of the ports on distribution switch 1 are in the designated role. Whoops, sorry about that. In the designated role. And so the state of all of those ports will be forwarding. As you can see here, we've got a number of ports that have a cost of 100, and then we have this individual port here with a cost of 10. Again, we have our port ID, which is made up of the priority and then the port number, and then we have the type of port. Now these all show up as shared because again, these are 10 megabit per second interfaces, and that is why they will show up with that's why they will show up as type shared. So if I were to roll up a little bit here, let's squeegee that off. If I were to roll up just a little bit in the window, what can we tell? Well, we've got the root bridge information here, and then we've got the local bridge information here. And so again, when we're looking at the root bridge, it's very easy to quickly see whether or not the switch that we're on is in fact the root bridge for the VLAN in question. And when you see this bridge is the root, then there's no question that this bridge is the root bridge. We can see the local priority here for this bridge, which is 28672. And then we have the system ID extension, again, that MAC address reduction feature, which allows us to differentiate things by using that, adding the additional cost of the VLAN number in. And that's how we end up with a priority 28673, because it's 28672 is the priority value, and then we add in the system ID extension value, which is the VLAN number. You can see that the MAC addresses match up, right? So there's no question this is the root bridge. And then we have our timers. Again, as a quick review, the hello timer. This is how often configuration BPDUs will be sent out the designated ports on this root bridge. The max age time, this is pushed down to all of the other participating bridges that are in this layer 2 domain. And then the forward delay time. So real quickly, the max age time, that would be if you had a blocked port that all of a sudden started to receive BPDUs that were inferior to the root bridge. So in other words, the max age time, the best example that I can give you for max age time is you have 4 switches, and we're going to say that this is the root bridge. So this would be the root port on this switch right here. Well, if that port goes away, right, and we'll say that this one was initially a blocking port, if that port goes away, this designated port here is immediately going to transition into it's going to think it's the root bridge, and so it's going to start to send BPDUs out here. And so then what will happen is, we'll say that this is switch C. Switch C on that port would start to receive BPDUs from, and we'll say this is switch D. From switch D, however, they would be inferior. And so switch C will wait max age time for the BPDU that it has cached on that interface. So it'll wait for 20 seconds for the information that it already had cached here, which was switch A is my root bridge, because this is the designated port. So switch D would have been sending the BPDU saying, hey, switch A is the root bridge. When that root port goes down right here, switch D says, hey, I don't care about A anymore. I think I'm the root bridge. So now switch C is receiving inferior BPDUs coming from switch D saying, nope, now I think I'm the root bridge. Well, the max age time, that is the max age time is going to be 20 seconds here. That switch C is going to wait for 20 seconds before he decides to do anything. And again, he's got a cached BPDU that said A was the best, so it's going to hold that for 20 seconds, and if it doesn't get anything that reinforces that, then he'll entertain, and we'll go through the listening and learning states. The other use of max age is when you have a topology change notification. And again, topology change notification, if it happens, let's say we had it happen on switch B right here, it would send a TCN over to switch A. Well, switch A is going to send a topology change notification out all of its designated ports, or not a notification, sorry, topology change acknowledgement out all of its designated ports. But what will happen is whatever VLAN in which that topology change notification took place are forward delay. And again, the forward delay is when we have topology change notification. So if B sends a topology change notification to A, and A is the root bridge, and this is how legacy spanning tree does it, 802.1d, A, right, who's the root bridge, will then send that topology change acknowledgement out its designated ports, indicating that, hey, there's been a topology change, at which point all of the other non-root bridges, they will set their MAC address table aging time from 300 seconds. They're going to set it to forward delay. So 15 seconds, and then it will flush any unused entries, and those will have to be relearned in the MAC table. All right, so let me go ahead and squeegee this off here. So let's continue on. So we've confirmed that distribution switch 1 is the root bridge. If we come over here to distribution switch 2, let's go to privilege exec from user exec and say show spanning tree. And what do we see here? Well, we see that the root port for distribution switch 2 is Ethernet 01. So to come back to the diagram, the root port for distribution switch 2 is right here. It is Ethernet 01, and that makes sense. If this is the root bridge, and this is a designated port, and this is a designated port, the cost for DSW2 to go that way is going to be more than that direct connection right there. So that is why this is the root port, and then you could see that it was selected as the designated port as well on Ethernet 00. So then now we're going to have to figure out what happens here. Well, my guess would be that this is going to be the root port, and that this port, if we have a designated port over here, that Ethernet 02 would be a blocking port. So let's check that out. Let's see if that is actually the case. Let's go to ASW, the access layer switch. We'll go from user exec to privilege exec, and we'll say show spanning tree. And sure enough, Ethernet 02 is listed as an alternate port, right? It's a blocking port, and you can see we are running the rapid spanning tree protocol. And that's another quick note about the Spanning Tree Toolkit. And let me pull up a really nice document here. If you were to Google, all you have to do is Google Cisco Spanning Tree Toolkit PDF, and you'll end up at this PDF right here. And it does a great job of sort of outlining when and where you would apply the different Spanning Tree Toolkit features. And in fact, it actually lists PortFast, Uplink Fast, and Backbone Fast. So it lists the 3 features associated with legacy Spanning Tree. We'll put a L there for legacy. And these are the survivors that made it with RSTP. So quick note, so PortFast is also included in this list here. So the 2 that are no longer used because they're incorporated into the Rapid Spanning Tree protocol are Uplink Fast and Backbone Fast. And now remember, it's no longer called a PortFast port, it's called an Edge port under Rapid Spanning Tree Protocol. And so we're interested in RootGuard, and you can see they say that you would apply RootGuard here and here, but then they also list it down here at the access layer, that you would have RootGuard there and there. Sorry, trying to line that up. So that you would have RootGuard at your access layer as well. And we'll talk about that, because typically on your access ports, ports that are facing servers, access points, whatever the case may be, user printers, devices that would be user devices, you typically want to have on RootGuard, PortFast, and BPDU Guard, right? Now again, this activity focuses on RootGuard, but it's a good note that you would have RootGuard, PortFast, and BPDU Guard on your access-facing ports. And now these are uplinks, right, between access and distro, and so we would place RootGuard here in order to protect the status of the root bridge. And that's really what the RootGuard is doing, is it's ensuring that superior BPDUs do not show up, you know, from a box that gets plugged in down here, and then those BPDUs start to get flooded out the different links. And so that's what RootGuard is doing, is it's guarding the position of the root bridge. But again, this is a nice little document. It gives you a quick synopsis of the different features, and then here at the bottom, here at the bottom, it actually goes into the advantages, right? And a little bit more valuable than sort of a sales pitch, but again, it does go into a little detail here, which is kind of nice. And then here's the one that we're interested in, which is RootGuard. So it prevents a port from becoming root port or a blocked port. And when RootGuard is configured, the port receives a superior BPDU. It'll immediately go into the root inconsistent state. And so if you think about that, it makes sense. Prevents a port from becoming a root port or a blocked port. Because if we were to change the topology for whatever reason, and this is kind of what we're looking at in our lab, if we were to change the topology and say that this guy right here, all of a sudden the access layer switch were to become the root bridge for whatever reason, misconfiguration, that he would be sending superior BPDUs out, and so you put it on the ports that you don't want to be the root port. Because think about it, if that's our designated one, or I'm sorry, distribution 1 and distribution 2, if this guy is the root bridge right now, that would be a designated port. And he would be the backup root bridge, that would be a designated port, like we have right now. But if this guy becomes the root bridge, these turn into root ports, right? Because they're closest to the root bridge. And so that's what this is all about. Prevents a port from becoming root port or a blocked port. All right, so let's squeegee off the screen here and let's transition back to the Learning Lab activity. So we did the show spanning tree on the 3 switches, and we can clearly see that the root bridge is DSW1. And so here's what we're going to do now. So we're going to change on ASW. We're going to make it the root bridge. So we're going to go into global config. I'm going to say spanning tree VLAN 1 priority, and they want us to set it to 2480. Now, do debug spanning tree events. See if it's too late. I should have kicked that on earlier. So what we're going to do now is we're going to change the root bridge. So now on ASW, if I say do show span, we should see that. And it looks like it's still showing in the alternate blocking state. And actually, let me make sure that's what they wanted here. Yeah, it should be forwarding on all of its ports. And let's see if it's just taking a while. So it still shows Ethernet 02 as a blocking port, but that should not be the case. That port should be rolling over to forwarding. Let's double check the priority here. we lowered it down. So yeah, so the priority on 2 is 28673. Priority on 1 is 28673. So do show span. And did it not take? Yeah, it looks like it didn't take our command. Huh. All right, so let's try it again. So spanning tree VLAN 1. Yeah, because what I was expecting was that all of these ports should turn into designated ports. And we didn't see that. So spanning tree VLAN 1 priority, and I'm going to lower it to 4096. Okay, there we go. All right. So it didn't like 2480, so I just dumped it to a lower value. And it looks like things are starting to happen now. So do show span, and it's going to, hold on, the E02, we've got the proposal process taking place here, and now it's in the learning state, and then it's going to transition here into forwarding. So the proposal is getting sent out on Ethernet 02. That's the one we have in the learning state. And you can see it generates that topology change trap, and there we go. So now we've got what we were looking for. We have all of the ports, because this is the root bridge for VLAN 1. All of the ports have a role of designated and a state of forwarding, right? Because this is the root bridge. And so what I just did right here was exactly what the root bridge feature, or RootGuard feature, has been created to stop, which is when we take a look now at DSW2, if I say show spanning tree, you can see that now Ethernet 01 is blocking. So if I come to the diagram on DSW2, this port now is blocking. So in order for any traffic on DSW2, right, to communicate with something connected to DSW1, it's going to have to come that way through our access layer up to the distribution layer, because again, this port is blocking. And this is exactly what we didn't want to have happen, because that has now become the root port, and this has become the root port. So Ethernet 00 on DSW1 and 00 on DSW2. Let's confirm that. On DSW2, Ethernet 00, as you can see, that's now the root port. And this is what RootGuard is able to stop from happening. So let's say show spanning tree. And same thing, Ethernet 00 on DSW1 is the root port. And so remember that definition we saw over here, right? Prevents a port from becoming root port or blocked port. And that is what the RootGuard is all about. And let's go ahead now, and let me take a quick look here what they want us to do next. All right, so we've already confirmed that the root port basically flipped. This is why we need RootGuard. And so now we're going to change the priority back on ASW1. So let's come back over here to ASW1, and we're going to say spanning tree VLAN 1 priority 32768. And we're debugging, so you can see right here we've got the proposal agreement process with rapid spanning tree taking action here. So when we do the show span in a second, we should see we've got some ports in the learning state, so we're going to let those continue on their way. But we should see that what's going to happen is that this is going to transition back to the way it was before. In fact, if we come over to DSW1 and I say show spanning tree, you can see that now DSW1 is again the root bridge. All the ports have a role of designated and have a state of forwarding. Let's go back to DSW2, who a minute ago had a root port of E00 and was blocking on E01. And now we see that that's not the case at all. His root port now is E01. Remember, that was a blocking port just a second ago when ASW1 was mistakenly placed in as the root bridge. And so now Ethernet 00 is designated and forwarding again. All right, let's go back down to ASW1 here. Hopefully this looks like that could be done. Exactly, and it is. So my root port is Ethernet 01, and then the blocking port is Ethernet 02. So again, we are back to the configuration that we previously had. So now let's go ahead, let's lock things down here on step 6 on DSW1, our distribution layer switch. We'll go into global config from privilege exec Ethernet 00, and I'm simply going to say spanning tree guard root. And that's it. That's the only command that needs to be run in order to enable RootGuard. So same thing over here. We're going to go into global config from privilege exec, interface Ethernet 00. I'm going to say, oops, spanning tree guard root. And what this is going to do now is this is going to be listening, do show run interface Ethernet 00. So this is going to be listening for a superior BPDU. And again, it would be superior if a bridge got plugged in anywhere downstream, right? So if a bridge gets plugged in anywhere downstream from the ports on which I have RootGuard enabled, right? And it could even be a new switch that gets plugged in here. And if it has a priority of 0, then BPDUs are going to start to flood this way saying, hey, ASW9, which we just pulled off the shelf and plugged in here as a replacement for maybe another switch that was plugged in over here, he's got a bridge priority for VLAN 1 of 0. So now those BPDUs would get flooded out that way and that way, but that is where RootGuard is going to come into play. And that is why on all the access-facing ports, that port right there included, this is why you should have RootGuard down here, right? RootGuard down here, in addition to BPDU Guard on host-facing ports. And these guys work in tandem with each other to protect your spanning tree topology. All right, let's go ahead and clear the screen here. And I believe we've got it on both DSW1 and DSW2. So now what we're going to do is we're going to go ahead, we're going to go to ASW1, or just ASW, and we're going to say spanning tree VLAN 1 priority, and I'm going to set it to 4096. So we should see some debug information. Again, you see that nice message here. Look at, we become the root bridge. So he immediately thinks he's the root bridge. If I come over here, we get some great syslog messages here. Spanning tree RootGuard config change. RootGuard's been enabled. And then what do we see right after that? When we made our change 2 minutes later, when we made ASW the root bridge, spanning tree RootGuard block. RootGuard blocking port Ethernet 00, because that's what you want. So this port goes into a blocking state. And that is exactly what we want, because we don't want to allow ASW to become the root bridge. Because you should never have your root bridge in your access layer. All right, so let's see, how could we check that, right? If maybe we missed this message, things stop working. If I were to say do show spanning tree, let's take a look at what it does. It puts the port into a root inconsistent state, right? And so that right there is a huge red flag that I've been receiving superior BPDUs, so I'm just simply going to move this port into a root inconsistent state. And if you think about it, this would be the equivalent of the legacy 802.1d spanning tree of the listening state. So he's in a listening state right now because he's still listening to hear, you know, kind of what's going on. Excuse me. But no traffic will be able to go across this port until this issue gets resolved. In fact, if I were to say oops, sorry about that. Click in here. Do show spanning tree inconsistent ports. Yeah, so if you say do show spanning tree inconsistent ports, you can see that it actually gives you a nice little output here telling you the VLAN that's affected, the interface where it's got a root inconsistent port, and it lists it out right here for you, right? So if I were to check on DSW2, we should see the exact same thing. As you can see there toward the bottom, we do. So do show spanning tree inconsistent ports. It's Ethernet 00 again. Do show spanning tree. All right, and there it is. So now the big question, can I enable guard root globally? So let's see, could I do that? If I were to say spanning tree, and if you take a look here, they've got loop guard, but no root guard, right? So we would want to put that down on the port. I prefer, I personally like to do it individually per port. So, excuse me. Again, you can see what happens here. So now let's see, will ASW1, like let's say the administrator figures it out and he says, you know what, that's right, 32768 was supposed to be, or actually, let's do this. Let's set it, and I don't know if you knew this, if you type in a bogus number here that's below 65535, Spanning Tree will tell you the values that you could put in. So let's put in 61440. 61440. And this is what I do on all of my access layer switches, is I always push the priority to 61440 because they should never become the root bridge or the secondary root bridge. So we'll set it to 61440. We should see some topology change information happen here, but let's see what happens. Does it automatically unblock the port for me? Or am I going to have to do something like a shut, no shut, in order to bring things back? Do show span. And this is one of the reasons it sits in that listening state, is because you can see what happened here is once we got rid of the bogus root bridge, or in other words, the bogus superior BPDU, RootGuard says, oh, okay. So, the bridge, the switches were listening, and so then the RootGuard says, yep, you know what? It's all clear. We can come out of the root inconsistent state and transition back to the forwarding state immediately, because those superior BPDUs that we were receiving, those have now gone away. And so it's safe for us to transition back into the forwarding state. All right. So this is going to wrap up the RootGuard feature. Again, extremely important feature that you would definitely want to use in tandem at the access layer. Oops, sorry about that. I'll bring the diagram back up. At the access layer, you want to have RootGuard on your host-facing ports, because again, should a PC be sending superior BPDUs? Absolutely not. So we want RootGuard there, and we want it there, and we want it there. So here's a question for you. Why would I not put it here and here? Why would I not do that? Well, yeah, because it's going to receive superior BPDUs coming both directions, because it's not the root bridge. Our root bridge right now is DSW1. So you wouldn't put it here. Again, you want to put it on ports that are protecting or guarding the root position, right? And that would be any of these access layer ports. You would use it with BPDU Guard. And remember, the BPDU Guard is going to be access layer only, because when a port gets a BPDU, it goes into an air disable state. And then you would want to use PortFast down here as well. So these three guys you should see on every host-facing port. And then here, it's just RootGuard, right? We're just going to use RootGuard. That's it. Because that's what we need here. We need to protect the position of our root bridge, and we can say that this is the secondary root bridge in all probability. And so that's what RootGuard is going to do for you. Now remember, RootGuard works with legacy spanning tree protocol, and it works with the rapid spanning tree protocol. Okay, so it is a tool in the Spanning Tree Toolkit that is available for both legacy spanning tree and rapid spanning tree. All right, well, this is going to wrap up this morning's video tutorial on RootGuard. Hopefully, this has sort of solidified your understanding of RootGuard, the sort of the when, where, and why you would want to apply RootGuard. And then we talked a little bit about the additional features at the access layer anyway, and host-facing ports, right, or printers, APs, whatever, where you would want to make sure that you use RootGuard, but then you team him up with BPDU Guard and PortFast. All right, thanks for watching, guys, and I will see you on Monday night.